Yeah, Charan. Welcome to the mock interview. Charan,
Sure.
we will
Thank you.
have 40 minutes, and in 30 minutes, we will be going through the questions, and I will be uh, asking you some of the questions related to stats, machine learning, and deep learning.
Yeah.
In the next 10 minutes, it will be a feedback and question answer rounds. Like if you will have any question for me, also. Hope that sounds okay to
Great.
you.
Sounds. Yes.
Okay,
Yes. Perfect.
perfect. So I have your resume with me. Let's start with your
Mm-hmm.
introduction, and uh, I will then go ahead with my questions. And also in those 30 minutes, we'll divide it like 15-20 minutes questions based on your profile, your projects, and other 10-15 minutes based on your that I will be asking you related to machine learning, deep learning, and stats. Okay.
All right. Yeah. Great.
Yeah, please go ahead.
Okay. So myself, Charan Bharadwaj, and I'm basically from Karnataka itself. And so I completed my graduation in 2018, and then I started as an intern in Qualcomm. And then I was converted to as a full-time employee there in Qualcomm, and then I served there for 4 years almost, and
Mm-hmm.
then I switched to Oracle. And to talk about my I mean the achievements or tasks that I've done in the past, right? So I've done a couple of projects on machine learning during my engineering, and one of the paper which got published in one of the journal as well. And yeah, mostly they were relating to medical data and basic machine learning algorithms. So those were the projects that I did during my engineering. And then during my internship in Qualcomm, I was mostly tasked for building intuitive dashboards and writing
Mm-hmm.
different SQL queries and building some visualizations using Tableau and uh, to certain extent Power BI tools as well.
Mm-hmm.
Uh, Also, I briefly worked upon writing some shell scripts and some Perl scripts and even some Python scripts, which would extract the data from historical simulation jobs. So when I say simulation jobs, they are just kind of simulation jobs which kind of emulate the VLSI chip which Qualcomm produces, right? Qualcomm produces SoC processors. So they kind of emulate those different processes that happen on the chip. So those are called jobs in Qualcomm. So we would take the historical job data to predict the resources that would be needed for future jobs that would be submitted. So those are the data as such. So and we would pour over the historical data and kind of create a specification for each kind of job, uh, like specifying how much memory, how much CPUs, and how much runtime it would use. So the project was involved around it was involving around those kind of aspects of a job.
Mm-hmm.
And yeah, those were the tasks that I mainly worked on during my internship in Qualcomm. And then later I was converted to as a full-time employee there in Qualcomm. And there, yeah, it was kind of a continuation of the prior work that I did during the
Mm-hmm.
internship. But again, it was a more kind of advanced ones, right? So uh,
Okay.
like doing a proper analytics uh, for the high
Got it.
performance jobs that we had in Qualcomm. Yeah, something like that. Also, meanwhile, we briefly worked on some NLP based ticket suggestion systems. It was kind of a spin-off project that we did on our own initially, but yeah, it gained good cognition among the management, and we had implemented it for one of the support teams that we had in the as an internal team. So
Okay.
that was one of the NLP based project that we did over
Okay.
there.
I
And
would be
mhm.
a bit interested in this project. Could you please explain it like what is the use case
Okay,
and
sure.
then how did you solve it?
Okay, yeah. Basically, this project was now we would have a support system, support teams in any organization for that matter,
Mm-hmm.
right? So they would be getting a lot of issue tickets. So in our use case, it was like it was a engineering IT team which would solve the issues pertaining to the VLSI engineering teams over there in Qualcomm. So basically, they would the issues would revolve around different type of environmental issues in Linux environments or any other type of environment, or jobs getting suspended or hung, or even different access issues, like something related to the Linux environment and the processors and resources, something like that. So it was that kind of issues that would be getting generated. And the major issue that we found out was like a lot of new engineers who were new to the new support engineers who are new to the system would really find it hard to basically suggest a solution, and it would take a lot of time for them, even if for a repetitive issue, like because there would be a lot of common issues that would come again and again, and newcomers would really find it difficult to basically give us resolution quickly. So that was one of the major kind of a cause that motivated us to start with this project. So what we did was we took a historical some number of issues that happened in the past, or incident tickets that were raised in the past, and what we did was we did a bag of words, and then we kind of associated the different words, different tickets using the keywords that were present. And also one another kind of a I wouldn't say innovative, one of the major change that we did, addition to just a normal clustering, was to basically assign extra weights to the particular keywords that would be very specific to set of issues. So this would be kind of a unsupervised, and somewhat supervised part was this, like where we would introduce some predefined keywords to basically help them get associated to a certain cluster quickly.
Okay, so
So
just stopping you here.
mhm.
So what
Yeah.
was the size of the data? Like how many tickets you had as historical?
The number of tickets was like depending upon like how much time period we took as a time window, but
Like,
yeah, it would
what you had, like
revolve around.
yeah,
Mhm.
if you remember any number.
Yeah, it was around 30,000 something like that, and we
Fair
had
enough.
like different data sets like 10,000, 5,000,
And
like different samplings as
so
well.
30,000 tickets. So you would have the ticket, what it was talking about, and also how it was solved, right? The details. Correct
Mhm.
me if I'm wrong.
Yeah, yeah. Yes, it would have like a like typical incident ticket. Like initially, it would be a problem, and then
Okay,
the resolutions and
let's
the
think just
workloads.
you had a ticket only. There's no resolution data. You just had ticket data, what ticket was raised
Mhm.
for. Okay. Now tell me
Okay.
the first approach that you said, the bag of word.
Mhm.
Just tell me how it was able to help you in identifying a similar ticket. So
Yeah.
what is bag of word? First, just tell me what is bag of word.
So bag of words is like it's a kind of a matrix which we create, and so the rows would be documents and the columns would be different words, and each of the word would be
What is
assigned a
document here?
weight.
What do you mean by
Document
document?
is in our case it would be a one incident ticket.
One ticket is your one document. So you are
Yes,
saying,
yes.
what you said, column. How did you define it?
Column would be words
Words.
involved in the whole of a whole corpus.
Okay, the corpus words, that is your column, and rows are your incident ticket
Incident tickets.
rows.
Yes.
Okay, and what do you feel there?
Sorry.
No,
Okay,
so that
filled.
that is
Yeah.
yeah.
So
Hmm.
it would be filled with the number of times that particular word occurs in that incident ticket of the document there.
Fair enough. You have that. Now just imagine I have a new ticket with me. Okay,
Mm-hmm. Okay.
I gave you. Now I ask you, give me the best matching ticket. How did you find it? How will you find it?
Okay. So first we would find like the with the new incident that is coming up. So we would just pick up like do the usual natural language processing stuff, like all the software removal and all those things.
Pre-processing.
And once
Okay.
we, yeah,
Uh,
pre-processing,
uh,
and then once we have the list of only important words, right?
uh,
So we would see like how many like across the corpus, like how many words that are there in the I mean, in this particular new document or new ticket, and we would find the most similar ticket using like cosine similarity or something across the matrix, right? So
No,
we
wait,
can find like
wait.
mhm.
Cosine similarity between what?
uh, cosine similarity between this new ticket which we have
How?
across all the other
Okay,
words.
for cosine similarity, what data you should have?
A matrix would work. So
Matrix of what? I'm giving you two words. Okay,
mhm,
he's a boy, she's a girl. Now tell me, how
okay.
would you able to get a cosine similarity between these two?
So I would find like so each word how much similar it is with the other one. So
How?
I to
Like, how will you
mhm,
identify similarity? The words are not matching, correct?
yeah.
Then how can you say, okay, or how will you be, so why you are doing cosine similarity? What you will get at the end?
A value which indicates the similarity between two words.
Two words, okay?
I mean two sentences. Sorry, two sentences.
Why not words?
I mean it can be words also.
Okay, so in your case, as I said, I gave you an example. He's
Mhm.
a boy, she's a girl, okay? What is the process to get a cosine similarity between these two? Using your method that you said bag of what?
Okay, so so in the back of now with these two sentences that you
Hmm,
gave, so we
hmm,
would have a corpus which would have all these words, okay, as a column,
hmm.
and in the row we would have these two sentences itself, and we in the matrix we would have weights for the words that have occurred in this each of the document respectively. So with that, what we can do is like we can find the difference between the corresponding values, corresponding words that occur, and then we can find out the similarity, right? So like it's in our case it's simple, like only two rows, so we can just find out the difference on the values.
And next question is why cosine similarity? What is cosine similarity? You said is to identify similarity, correct?
Mhm.
So
Yeah.
at the end, what value I will be getting? So as you said, you will be doing you created a corpus, and now you will be putting that in a cosine similarity formula. What you will be getting at
Mhm.
the end?
So we'll get a value between 0 and 1, and
Between
which
0
would
and 1?
indicate sorry, -1 to +1. Uh,
Why?
so because the cosine values like they oscillate from -1 to +1.
Okay. So so I have 0.15.
Mhm.
What does it mean?
So it says that like you want me to explain it in terms of like slope or something, or
Mm, yeah, like okay, yes, like I'm giving you three values. Tell me what. I have a 0, I have -1, I have 1. Now tell me,
mhm.
what are the different you know understanding you have using these three values as a cosine?
Okay, so when we have a positive cosine value,
Hmm,
so we can say that they're kind of matching in a positive way, or correlated in a positive way, and when it is 0 we can say it's like neutral, and I think I'm going wrong, so I'm not very confident on that answer, but
okay,
yeah.
no worries.
uh, yeah, and negative I think it's like negatively correlated.
Is a cosine is a distance formula? Cosine similarity. Have you heard about cosine
Yes.
distance? Okay. So why
Yeah.
cosine only? Why not Euclidean, Manhattan?
Like, are you asking like why did we use that there?
Yes. Why did
Okay.
you use cosine?
So among the others, we found like the cosine was like kind of a simpler one. And yeah, I mean, honestly, we didn't have much idea of other similarity distance. I mean,
Like
similarity matrices. I
Euclidean
mean,
is quite famous, right? Whenever you want to get a distance between 2 points, right?
mhm.
You use
Yes, yes.
Euclidean, right?
Euclidean is also can also be used, but um, yeah, I mean, I don't remember like there was any strong reason that we
Reason.
went with the cosine similarity, because see,
Hmm.
even then, even the Euclidean distance, as you said, could have been used there, but
Hmm.
yeah. So in that case, I think if I remember correctly, so cosine was giving like more better values as a overall model. So that's that. I think that's the reason we went with the cosine similarity, because I remember we had tried with uh, different, I mean, the similarity measures like Euclidean, as well as uh, some other like Manhattan distance and all those things as well we had used,
Oh,
but cosine was giving us better values.
okay. Have you heard about TF-IDF?
Yes.
How it's different from bag of words?
So in bag of words, there is one native issue that
Mm-hmm.
like if the word something which like very word is occurring in a very common way, like if your word is very common, right? So it would ideally get like very high value,
Mm-hmm.
even though it may not be a important word as such. But uh, contradictingly, in TF-IDF, it's opposite of the of this case, right? So in TF-IDF, we if a word in a document or across the corpus, if it is occurring very
Mm-hmm.
frequently, then
Mm.
the TF-IDF will reduce its importance, or basically reduce the TF-IDF value of that particular word, so
Mm.
that we won't end up with very common words that may not give us uh, like required insights, or particular like value to the it won't give us like valuable insights from the corpus. So that's
Okay,
the main advantage of TF-IDF. Yeah.
fair enough. Uh, what was your metrics here, like evaluation metrics for this model?
Yeah. So on the coming to the evaluation metrics, so since we use the clustering model,
Mm-hmm.
and we didn't have much idea of like evaluation metrics for the clustering model, so we kind of went with a kind of a manual approach,
Mm-hmm.
wherein we had a feedback system
Mm-hmm.
asking whether it was helpful for them, like a kind of a rating system kind of thing.
Okay,
So I mean, yeah,
but
it's not related to
if
machine
I
learning, but
say
yeah.
to give me any evaluation method for clustering,
Okay.
are you aware about anything?
Yeah, there are few. There are few clustering. Not getting it on top of my head. But
Okay, no worries. Leave it.
yeah, there are few
Um, so
clustering.
what are the different types of clustering that you are aware about?
So one is k-means clustering,
Mm-hmm.
and nearest neighbor, k nearest neighbor,
Mm-hmm.
and the hierarchical clustering methods. Yeah, these are few of them. Like there are again kind of variations of those uh,
What are
main clustering
difference
mechanisms.
between k-means clustering and
Mhm.
hierarchical clustering?
Okay, k-means clustering, it here the algorithm iteratively assigns a mean to a set of values,
Mean of
and
what?
mean of the distance. It would be like a mean of the distances between uh, the individual values to a centroid of that particular cluster.
Okay.
And then like in different iterations, it kind of goes on improving the distance, and changing the
Mm-hmm.
position of the centroid, so that it at the optimal stage it would have all the points that are belonging to the particular cluster that are like very near to that particular centroid, and this is how the different clusters would be formed. And yeah, in that case, like each centroid would be having the points which are very near to that particular centroid.
Okay. Then what is hierarchical?
In hierarchical, it would be like a for starting with each point would be treated as a cluster, and then we go on merging to clusters, and then
Mhm.
we would enter a point where we have enough number of clusters, and the nearest points would be forming a cluster amongst
Okay.
themselves. So
Just think of a scenario in K-means clustering. At
yeah.
what point of time you will say, okay, these many clusters are enough?
Okay, so since it's a unsupervised learning mechanism, we don't have a hard rule that this is the optimal number of clusters that we can have for this data set. But there are some methods like elbow method, which will say like what's the optimal number of clusters that we can use for
What is
this
elbow method? How it
data
says?
set. So elbow method will I don't remember exactly the
Do you remember the graph?
measure. Yes, yes.
What is x-axis and what is y-axis?
So y-axis would be number of k,
Mhm.
and x-axis would be, I think it's some error. I think it's a square of the distances or something like that.
Okay,
Square
no
root of the
worries.
distance or something like that. Yeah, and it would look like a elbow. I mean, it would first like it would come down at some point. It would come down sharply, and after that,
Got
it
it.
will kind of look flat. And yeah, that point would be, we would treat it as an optimal K for
Okay,
that data set.
no worries. Yeah, fair enough. Okay, next, just I'm moving to stats quickly now. Okay.
Sure.
What is central limit theorem?
Um,
If you don't know, you can pass. So we can move quickly to the another one.
okay, yeah, I mean, yeah, it would not come directly right up
Sure,
on
no
top of my
worries.
mind, so I would pass.
Okay. Um, okay. What is null hypothesis and alternate hypothesis?
Okay, so null hypothesis and alternate hypothesis are like we in machine learning domain, we kind of have two statements. Say this this particular variable is depending this independent variable is affecting the dependent variable, and maybe we can call it like a null hypothesis as the contrasting one. And we try to prove that the alternate hypothesis that we define, which we are going to use as a for the hypothesis testing, is going to be true. So we kind of perform a set of experiments to prove the null hypothesis as wrong.
Okay.
So so like we can start with like we can just say like the weather which is for a day is going to affect a person's habit of going out. So in that case, we can have a null hypothesis saying that weather doesn't have any effect on that person going out, and the alternate hypothesis can be it has effect on that. So
Okay.
then we try to prove that the null hypothesis is wrong. If we like statistically again, if we cannot prove that, it kind of means that the null hypothesis is correct and it doesn't have any effect, and we cannot process. I mean, kind of it's not useful to process any further. And if the
Got it.
alternate hypothesis is true, yeah, we can kind of go ahead with the further processing.
Sure. Just choose one modeling technique or algorithm from supervised learning. You can pick any.
I would go with decision trees.
Decision tree. Okay. Uh, how do we identify impurity?
We can go with Gini index or maximum entropy. Those kind of
What a
impurity.
difference?
Sorry.
What a difference between these two?
Maximum entropy will give us the I mean, these are kind of related, but maximum entropy will give us the split, which will give us the maximum information. So
Mhm.
yeah, I mean, I think so I think, yeah, maximum information gain is in term using maximum entropy. So yeah, I think information gain is the correct right answer.
Okay. Uh, where do we use decision tree? Is for regression or classification?
Classification, yeah, it's for classification.
Okay. Um, just tell me some evaluation metric.
Like in terms of classification or
Yes.
any evaluation.
Classification.
Okay, for classification we can have accuracy, precision, those precision, recall, those things.
What are the difference between these precision, recall, and accuracy?
So precision, accuracy would be the ratio of true positives to number of prediction. I mean, the in layman terms, it would be the ratio of number of data points which are predicted as true to the total number of actual true points. So that's accuracy. And recall, the precision would be number of actual true points that are rightly predicted to the total number of true points, actual true points.
Okay.
And recall is remembering the formula. So it's just like we can say it's like number of I think actual true points to the ratio of total predicted true points, something like that. Yeah.
So if you have a data set which is imbalanced, which one
Okay.
you will pick?
Imbalance. Okay, which accuracy metrics? Sorry, which evaluation metrics that I would
That's
pick,
correct.
right?
Yes.
I'd pick precision. Yeah, I'd pick precision because so precision would kind of help us with, even though the data is imbalanced. So what happens is, like with accuracy, we kind of get a biased results because one of the classes might be in huge number, and even though if we had almost all the wrong predictions for a lower class, then even then the precision, I mean the accuracy would be higher. But in case of precision, we would be taking only the actually predicted true values, right? So then I think it will give us more insightful result.
And recall? Recall is also?
Recall is also same, but yeah, I think precision and recall is just one of the numerator are different.
No
That's it. Yeah.
What is bias and variance?
So variance is like how much the values are differing from how much the predicted values are different from the actual predicted line. So yeah,
that is what, like, this is what, bias or variance?
This is a variance.
And what is bias?
I would pass this.
You can escape me. Yeah. What is the formula for linear regression?
It would be EL equal to mx plus c. Sorry.
And what is the cost function?
Yeah. Cost function, right? So cost function would be summation of y minus y square. Sorry, y minus y hat, which will be sorry, summation of y minus y hat whole square. So here y would be the actual value, y hat would be the predicted value.
And do you know how we optimize it?
Optimization here would be minimizing them using mean square, sorry, least mean square or something like to basically reduce the the error values,
Okay.
loss
Uh,
function values.
okay. We are on time. So we'll
Mhm.
stop it here. Now we'll move to
Okay,
the
sure,
section for feedback and
sure,
Q&A.
yeah.
Okay. So, Sharon, like, how do you find yourself here? Like, out of 10, what you will rate yourself?
Yeah, I mean, I would rate myself like 6 maybe today. So
Yeah.
I feel like, yeah, my preparation was like not like not
Yes.
adequate for the interview, because see, for many of the questions which you asked, so
Hmm.
I kind of knew the concepts, but like I hadn't refreshed it enough. So that's what I felt like, because the questions that you are asking was like pretty basic
Mhm.
machine learning questions, and yeah,
Right.
I should have refreshed the formulae and some of the basic definitions of them.
Yeah.
So that's what I feel.
So,
Mhm.
yeah, definitely. So I will also write you, like, sorry, rate you, like that only 5 to 6. Okay.
Mhm.
Um, there are a few things that, yeah, I can clearly see that you haven't revised the concepts because, as you said, these are really basic. But yes, you are not the one even who appear in the interviews. Most of them like this, like
Yeah.
few concepts they know and few they don't. Okay. One
Mhm.
thing is really amazing with you that your confidence, whatever you answer, you're giving that. If you know, you are uh, just giving it in the way that it should be, and you're not
Okay.
hesitating. If you're not knowing, you're passing. Yeah, few places definitely you have gone like even the wrong answer you have given with the with the full confidence.
Yeah.
uh,
Yeah.
and way of speaking, presenting yourself, that's really good. Okay. Now,
Thank you. Thank you so much. Yeah.
coming to the technical part, uh, yes. So starting with the your introduction. So what happened?
Mhm.
So one mistake you have done. So I can see your resume. You have done this NLP project in your previous organization, right?
Yeah.
And you started talking about it, and I don't see any other projects which I could relate to, like any you know classification or any other NLP projects apart from this. So this was something other was is like either engineering, bit of engineering or analytics like ADA sort of thing, right? This is
Mhm.
the one.
Yeah.
So as soon as you and I'm pretty much sure you are not you don't remember everything of that project. Okay, because the
Mhm.
approaches that you're talking about, bags of what, that's definitely that never gonna work for such cases because you
Yeah.
can't just simply match words. If when you're building a model, it is a really bad one. Okay,
Mhm.
now so always try to not speak up about projects which you are not confident on. Okay, just
Okay.
let them pitch in. But if you have mentioned something in your resume, make sure you know every bit of it. You know you have full command over it. Okay, so
Okay.
you must work on that project because that's eye catching and people will ask you left, right, center. Okay,
Mhm.
so
Sure.
what is the solution? Now the solution of those things are really easier these days. Just get a embedding and get a cosine similarity between those embedding, and you have the best uh, best matching ticket. Okay, and
Mhm.
that's really really good solution with the minimal of effort. Okay, so just
Okay.
go through it and just see how to get a vector embedding of ticket and how we can get cosine similarity. Again, the cosine similarity question there, that was wrong. Okay, you when you work on this vector embedding, and you can't take Euclidean because Euclidean is something. So what is the embedding? Embedding is something representation of word in a vector space or a sentence in a vector space. Okay. Now
Okay.
you can't calculate a distance of a vector using two, you know, like Euclidean distance there. You need angle between these two. Okay, because in magnitude one could be really high, bigger, and one could be smaller, but they are similar to each other or near to each other. Okay, so you
Mhm.
need
Okay.
angles. That's why we pick cosine similarity, which is nothing but a angle between these two that shows that how close these two are. If the angle is 0, the cosine value will be 1, right?
Yeah.
So
Understood.
so that's how it is. So that was the one. Uh, mm, Again, coming to the next, you're uh, mm, talking about talking about those imbalanced data set. That was also not completely correct. We mostly
Mhm.
take F1 score, where is a harmonic mean of precision and recall. Okay,
Okay.
so there are few things that and other like cost optimization. So few things that definitely I would request you to prepare for. One is
Sure.
one project which you are really confident on. I will say this NLP project, but just do some research, prepare it accordingly, that how we can
Yeah.
solve it. And it's really very simple and easy solution, and you will be knowing
Okay.
everything of it. This
Sure.
next one will be evaluation metric. Okay, that is something
Mhm.
favorite for the interviewers. They will ask you
Okay.
definitely for, especially for a classification, because that is just something that we use like anything, right? In the industry, 70-80% use cases comes for classification only. So
Mhm.
prepare for that. That okay, how you can get like precision, recall, uh, F1 score, F2 score, okay, AUC, ROC curve. Okay,
Yeah. Understood.
then next is like linear regression. There are few questions that is really hot. One is the linear regression formula, cost function.
Mhm.
That was correct,
Yeah.
but it was partially correct, I would say. You haven't seen 1/2m. And then it is like the third is the cost function optimization, where we use gradient descent. What you
Mhm.
is
Okay. Yeah.
talking about I think you said root mean is RMSE, right? Or
Yes.
RSE. These are the evaluation metric for the
Metrics.
linear
Yeah.
regression. These are not the cost optimization function. Okay,
Right.
how we optimize the cost. Then in the stats, it was null hypothesis, and that was question answer was okay. And just go to central limit theorem. That is something central limit
Yeah.
theorem, VIF. And then I didn't have time, otherwise I would have touched a bit of like t-test, f-test, and then
Okay.
uh, mean, median, mode, and also distribution.
I
Okay,
see. Yeah.
overall I believe like you're confident, you are able to explain things properly. Only thing
Mhm.
I will request you to brush up your knowledge, just
Yes.
revise things.
Definitely.
And very important thing, whatever you are writing in the resume, okay, you
Mhm.
must have completely command over it. Like people can ask you anything from those projects, and you must know about it. Okay, and out of
Yes.
these
Right.
things, what I see in resume, that is only NLP projects that is getting highlighted, and people will ask you.
Okay.
Okay,
Understood. Yeah.
do you have any questions? We just have
Um.
1.5 minutes.
Okay. First of all, thank you so much for doing this. This really helps
Mhm.
everybody. So thank you so much for that. And yeah, I mean, this is like a much of a kind of a personal question. So the
Yeah.
like maybe you can stop the recording if
Okay, wait.
it's
Yes,
okay.
definitely. I can stop it.
Yeah.
Right. Just a second.